The grass seed problem. Excruciatingly difficult, tantalizingly easy. This is one of those problems where once you have the key and once it's well practiced, it just pops off the page at you. But until you do, it's just this mess of math and algebra. Let's take a look here. One of the first things to notice is that we're dealing entirely in relative information. So bing, 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 running a scenario is a really good way to approach this problem. The difficulty in this problem though, is that we don't have any basis. We don't know how many bags of grass seed there are. And that throws a lot of people off. So notice that once you understand that the answer choices are all relative, it frees us up to use any number of bags we want. And this has to direct us to the pivot question. How many bags of mixture X offset mixture Y, or vice versa? That is, much like other problems where we don't have precise data, we need to kind of assume amounts of data that are undefined and then get an answer and build backwards. This is a little weird until you try it on a few times and get used to mentally wearing it. So let's take a look at bags X and Y. We're being asked about the amount of ryegrass, which means that the amount of fescue, the amount of bluegrass, whatever else is in the bag, doesn't matter. Bag X has 40% of what we're looking for. So if bag X is 100 pounds, it has 40 pounds of what matters. An easier way to think about this is if you're told about salt water. You can almost imagine separating the salt from the water. The same thing's happening here. You take this bag mixture and just separate each grain out until you've got 40% of a bag that's just ryegrass, 60% that's other stuff. Whether it's one thing, whether it's four things, doesn't matter. Similarly, with Y, we have 25% of what matters. The core pivot question here, again, how many bags of Y do we need to offset a bag of X? And we say offset X, X has 40%, our target is 30%. And Y has, by definition, less than 30% because we're using it to offset. That is, whatever target amount we're going for has to be in between the percentages of the two bags. There's no way to mix up X and Y to get less than 25% concentration or more than 40% concentration. So that answer can be done via scenario. Let's assume we have one bag of X, and let's call it 100 pounds just to make things nice and easy. 40 pounds of grass seed, of ryegrass, is 40%. If we add one bag of Y, we have 200 pounds total, with 25 and 40, 65 pounds of ryegrass, or 32.5%. Again, because we're dividing by 200 pounds, bringing it down to percentage. We're still too high, we're still above the 30. So let's add another bag of Y. Then we have 40, 25, 25, 90 pounds of ryegrass out of 300 pounds of grass seed. Bingo, 30%. The ratio is one bag of X to two bags of Y. So X is 33% of the mix, 1/3 of the mix, Y is the other 2/3. And that brings us directly to our answer choice of B. We can also see this graphically. And by mapping it out graphically, we actually see this is a weighted average problem where we just don't have the weights yet. But take a look at this picture. The 40% we have from a bag of X is 10 points over. And every bag of Y has a 5-point deficit off of our target, which means that we need two bags of Y that'll make up 5 points each to distribute the 10 points we're over on X. Another way to look at this is via ratios. 40's difference from 30 is 10. 25's difference from 30 is 5, and we're dealing in absolute values here. The ratio of 10 to 5 is 2 to 1. In other words, we have to flip it to have a 1 to 2 ratio. For every 1 overage of 10, we need 2 underages of 5. You can use whatever language works well for you, and I encourage you to explore. Your own inner vocabulary is going to be essential for driving this problem. But as long as you find a way to anchor the concept here to not the entirety of the grass seed bags and their concentrations, but really just to the 40 and the 25 and the 30 and how those interact, all of a sudden this idea of percentages and this bigger sort of picture of these grass seed bags diminishes, and you have a very workable system that allows you to deal with concentrations at any level, be it a saltwater problem or a concentrated orange juice problem or whatever the GMAT throws at you. The important part is to take the story, make it your own, and understand what drives the problem and what they're putting in front of you that's a distraction. For other examples of problems like this and other useful problems, see the links below, and I look forward to seeing you next time.